3, 2, 1. And we're back with another talk for our QGIS Open Day, January 29th, 2021. And I'm joined by Jorge Gustavo Rocha from Portugal. And he's going to show us how to generate our own point clouds from using ODM, the OpenDroneMap project. And if you watched the previous talk, you've seen that QGIS 3.18 is getting support for point clouds. So this is kind of the logical continuation of that previous talk, because now George is going to be showing us how to actually make our own point clouds. So thank you, George. Welcome, and over to you.
Thank you, Tim. Nice to be here and to talk about this. And it's really nice to have QGIS supporting point clouds. And this presentation it should be before the previous one. So let's go back and see how we can create point clouds. Martin already mentioned the LiDAR and so on, but for this presentation, I've prepared on my GitLab. I've uploaded a data set. Just one moment. If you follow, yeah. If you are able to see this URL, which is, I can copy and paste it maybe on YouTube.
If you put it in YouTube, I'll put it in the description.
Yes. Yeah, I think I've shared it on YouTube. So my presentation is this making point clouds. It's a PDF and a Markdown. And for the images that I will use are here. So if you are able to install and make OpenDroneMap up and running, you can use this 0 set. And if we have time, or you have time, you can also use the other data sets for this introduction. So back to the beginning, the point clouds, the one way that Martin already mentioned is using LiDAR, and it is good. It is more precise, but it's hard to do it by yourself. The sensors are much more expensive. They consume much more power, and so on. So LiDAR is usually seen on airplanes, as shown by Martin, and also on cars. Google-like cars has this LiDAR on the top. It also good. The LiDAR can be used for off-road, and for example, Lynn, which might be here. Yeah, Lynn is here. I'm seeing her on the comments. For example, has a LiDAR on the backpack, and it's good to go off-road and to go, for example, inside the forest. But LiDAR, as I said, it's expensive, but it's good for large areas. The things that we want to use here is to capture these point clouds from images. And it's because cameras are really less expensive and much better right now. So it's easy to have cameras, lots of cameras and lots of images. And the base algorithm behind this is a structure for motion. We'll mention this later. And also we can use video and take frames from the video and use the same structure for motion from video frames. Usually, due to the video compression and so on, usually it's not so good to take frames from a video, and the results are not so good as from static images. But it's also due to the way the CMOS, the sensors of the cameras are made, and usually the way images are captured for video is different from photos, but it's a more technical detail. So to able to reproduce the things that we'll do here and to make your own point clouds, we'll need a drone with a camera and a GPS. These consumer grade drones already has this cameras, might be a 4K camera or better, or a GPS or even less resolution camera, but at least you need a drone with a camera and a GPS. You also need some kind of flight planning application. You can do a free fly and take the pictures and so on, but usually you will miss some places, you will take too many photos from the same place and so on. So it's much better if you use a kind of flight planning application where you can are able to draw a polygon, an area you want to cover, and the software will calculate the flight and will take pictures at a certain distance and with a certain cover and so on. So I right now use a drone, which is a consumer drone, a Mavic Pro. You can see the drone here, or you can see the drone in my pack. It's really nice to travel with it and go and capture the images. Sorry, and to do the flight planning, I use this Pix4D Capture. There are lots of applications for Android, which is what I'm using, and there are advantages, disadvantages. This Pix4D, I really enjoy it. It works really great. The only limitation I found, it's not able to complete a mission if you have to abort a mission, for example, with low battery. And for example, these dual grids missions sometimes can take longer. And if you have to change the batteries, this software is not able to continue the mission. You have to redraw it and do some manual stuff. Only linear grid flights is able to complete the mission. But talking about missions, this software and others equivalent softwares are almost the same. Some have more different flight missions. The usual flight missions are these polygon missions, where you draw the polygon around the property, around the neighborhood you want to fly. Or if you have a more square area, you can use these grids or this double grid. So you have two different flies. So we cover 4 directions, while in these flights you only have 2 directions. In this flight you have 4 directions, and you also have, for example, this kind of circular grids, which are good for a cathedral or some to reconstruct some sort of buildings. And you also can do free flight, but as I said, it's not so good. So things important from this presentation. Maybe some good practice that I want to discuss with you. Yeah, people are commenting about flying with the drones license and so on. maybe we can talk about that later, but it's really, there is a problem regarding licenses and regarding permission to fly.
George, also just we never got the link come through to the channel for your GitLab repo. If you could just share that again.
Oh, really? But copy, paste, isn't in the YouTube, in the chat?
No. Maybe you can just put it into the Jitsi chat for me, and then I will put it in the YouTube channel.
Sure. But I'm seeing the chat and I'm writing in the chat.
Yeah.
It's discrimination. Sorry. Why? So it is. I've sent to you, but I can also share it on the Telegram.
Okay, I'll put it into
thank you
the other chat.
For
thank you.
Pointing out, because I thought it was there. So back to the good practices. One is related to the flight height, the altitude of the drone. These drones are able to fly from 10 meters to 100, 200, and also there is regulation about the maximum height that you can fly. But usually I fly up to 100 meters and never higher than that. Usually less than that, about 50 meters, 70, 80 meters. But the first recommendation is not to fly below the altitude you need, because as we will see, processing these images is quite cumbersome. It will take many resources and so on. So don't try to have too much information, because it will be a problem. And it's not only a problem, but also the quality is not better, sometimes worse, even if you have more detailed images. For example, I have worst orthophotos from flights flying too low. So it didn't improve in any way the orthophoto. Also, we are mostly interested in maps and usually use the camera in a vertical position, call it nadir, 90 degrees. And that's fine. And even with this position, we can have the point clouds, we can create digital terrain models and so on. But if you want to improve the quality of the point clouds and the quality of the 3D models, you have to fly with some kind of angle. 70 will be sometimes good, but even sometimes you have to use less than 60, like 60, to capture better the facades of the buildings and so on.
George, could you just zoom your browser in a bit, please? Some people are asking that they can't read the text so well. If you just, thank you very much.
Good. So the recommendations basically are: do not fly too low. We'll get too much images and will take much time to process, and will not have better products on the output. Use the camera always at 90 degrees if you just want the maps and the basic digital terrain models and even the digital surface models. If you want to play with point clouds and if you want textures for the point clouds on the facade of buildings and for some kind of terrains and some kind of trees, fly with the oblique camera. Another thing quite good in OpenDroneMap is that you can do both flights and combine and use the photos. So you can fly, for example, have this A fly using a double grid with an oblique camera and fly above with a single flight with the nadir position. This will be fine, and OpenDroneMap is a of all the mesh. So mouse is so let's see what is OpenDroneMap and how it works. There is a link here. It is easy to find it on here. And OpenDroneMap has several products here. We can see, for example, two that are that I will talk about today, this WebODM and this Node ODM. And WebODM is a very intuitive way and a very nice way to use all this software stack behind the OpenDroneMap. With WebODM, we'll get a web interface, and everything is going to happen through this web interface. So even before we try to install and so on, let my interface here. So this is the web interface. You have a dashboard, interface for ground control point, and so on. But this interface is what you will use to interact with the OpenDroneMap. So you can add projects, you can see projects here. Under zero is this one. So you can see these 30 images are already processed, the task is completed, you can download the assets, view, and so on. Everything is done through this web interface. So back to our presentation, the preferred way to work with OpenDroneMap is to use this WebODM. So start with the WebODM and keep using WebODM. If you go to trying to install the components and so on, the operating system will be much more harder to manage the entire software stack. Of course, if you want to develop, if you want to tweak things in the pipeline that are not exposed in the interface, you have to install OpenDroneMap and tweak the pipeline. But usually, for start, you don't have to do that. Just use this WebODM. The WebODM is quite simple to install. It's based on Docker, and if you have previous experience Docker, you will find it easy to install. In Windows, in Linux, and Mac, I think it's really easy. Sometimes is in Windows it's complicated. It's complicated because the virtualization might not be active and so on. So sometimes it's not so simple to install it in Windows. But I will not enter the details here. If we move to the WebODM, in WebODM, in the documentation, you have a nice README here, and in this getting started, you have all the things that you have to run Open Web ODM. And if you have these things installed, which are typically already installed in Linux, maybe Docker or Docker Compose is not, but it's just apt-get Docker IO and Docker -compose. And after installing this, you just run these three command line commands. The first one is to clone the repo itself, because the repo itself has this nice script, and instead of controlling the Docker, this has two different compositions. So WebODM has two different Docker compositions, and instead of manage each composition by yourself and so on, you have this nice script to do your interaction with the Docker. So after you run this WebODM in your terminal, will end up with something running on port 8000, which is the default port. So the installation, you can check details and details more related to Windows and so on, but it's almost as simple as having Docker running, having Python and Git, and use the script to start everything. The advantage is that it's everything is in the Docker image, so everything should work. If you have Docker working, everything should work. And we will start by selecting a password to create an account. This WebODM interface can be made public, so you can make it available to others. For example, this one is running in my desktop machine here at home, but I also have it available from the outside. So if anyone wants to play with this, I can share the link to my computer, and you are also able to manage accounts. For example, these accounts are for my students, so they can come here and play with sometimes students without enough RAM to run this OpenDroneMap uses my machine. I will talk later, because this takes many resources, and if you use many images, it will take some time to work. It's super easy. If you have two computers with WebODM, you can use both computers, and it's as simple as having here more processing nodes. And for example, in this configuration, I have my laptop I'm currently using for the presentation is this node here. So I've installed it also in my laptop and use my laptop as a processing node, and I will show how to do it. And it's easier. It's easy. You can install WebODM in both, and if you install WebODM in both, you also install the node that is doing the processing. But going back to the OpenDroneMap, if you just want to provide the resources for another instance of WebODM, use it, you can install or just run Node ODM or ODM, and you can run it from Docker, so it's even simpler. You can see here how to run it. It's as simple as Docker run -p port 3000 and run. And that's exactly what I've done in my laptop here before the presentation to make this node, one more node available in my WebODM. And it's good because if you have lots of things to processing, you can add several nodes here and have a common interface, but the processing can be done in other nodes. Back to our presentation. So the first example that I'm suggesting you to use is this data set, this zip. It has just 30 photos. It's a chapel near my house. So how we do this in WebODM? So to process these images, so let me see where the image are. So this is the folder where I have the images. So if you extract the zip, we'll end up with a folder of these images. So I think if we have time, you can see, we can open QGIS just to have an idea. Let me open QGIS. Let me check another profile. So just to have an idea of what kind of photos, these photos have a georeference. The EXIF in the images tell us where the images were taken. So if you come here to QGIS, for example, you can install a plugin called the Import Photos, which is a nice plugin and really handful to do this. And you just tell where the images are, in this case in documents, in this OpenDroneMap to QGIS, this folder. So we select the folder and then select the output location where it will store a shapefile with the location of the photos. So I will select the folder here and select and call it photos. Okay. So 30 photos were added without error. So we are not using OpenDroneMap, but just seeing the photos here. And if you use, I think it has also a click photos. I don't know if it works immediately. I don't remember exactly all these click photos. Yeah, but if you use the regular tool, you'll see the photo here, and it's just a matter of going to the usual stuff in QGIS. In this case, for the attributes form, you could, it was the path, I think. You can use an attachment, and for the attachment, you can use a image viewer. So if you come here and click on the photo, you can see the photo immediately here. So these are the photos that we will process. And if you have something like Quick Map Service, good, and you open a Bing satellite or something, you'll see where the photos were taken. My house is somewhere here, and these are the photos, and you have at least one feeling of what you are doing here on WebODM. Back to the ODM, you create a project, you just give a name of the project. This will be the Friday project. You can create a description. Usually in the description, I say the altitude 80 meters, 80 meters, Nadir, and some other information related to the project, which is nice to see the description here. So to start using this is as simple of going here where you unzip the images and just select all images. Open, and OpenDroneMap tries to do a reverse geocoding to give a proper name where the images are. So he already knows from the images where the things are, but just the raw position, and tries to do the reverse geocoding and tries to put a nice name here. But usually it's better to write your own name here, but it's even it translated to Portuguese. It's the old chapel of my very small village. So you can give it a name and you can keep all the default options and just go and review and run. But since we already are here, in this particular case, since I've added another node, you can use the auto, or you can use a specific node here to say which node will be used in this processing. And the default option is to do a resize of images. These images from this drone have more than 5,000 pixels width, so it's wise to reduce the image size, and also the options will use the default options. And my suggestion is to use the default options for your first run, but at any time you have here many options to we can go here. And as you can see, you have many options to enable, disable, and all these options are related with the different stages of the pipeline. So, for example, PC-ATP or PC-LAS are options related with the point cloud, and in this case with the if you want the export of the point cloud in just compressed LAZ, or if you want to uncompressed LAS, for example. So these options are for for the pipeline related to point clouds. Some are related to the structure from motion. We'll see this later, but the wise option to start is to keep this as the default. So you have an option to review and then start processing. And the starting, as you hit starting processing, the first step is to upload the images. It was just 30 images. It is fast to upload the images. So the images are already on the node side, the processing node side, and in the process node, you already did the resizing, and you'll use the resized images to do the first step. If you want to check the details, you can open the project, and you can come here and turn the task output on and check what is going on. So you have a live log here, And we want to see what is going on in this stage, is doing the structure for motion, and is now trying to find points, the same points in different images, and so on. And it will take some time to do this structure for motion. It will be faster if you reduce the size of the images. If you keep the original image resolution with thousands of points that you have to do in this SIFT algorithm, but it's an option. So while this is running, it is running 1 minute and 30 seconds. Let's go back to our presentation and to have a notion of what is going on. So OpenDroneMap normal pipeline is this one. So these are multiple steps. And the first one is loading the data set. There was a small step here, not listed, but we can have a small step here. It was resizing the images, and afterwards we'll start with the structure for motion. I've wrote here just a very, very simple description of this, because it's quite technical stuff. But if you want to learn more about each of these stages of the pipeline, you can Google it. But the structure for motion is really one of the basic techniques for this to work. It started with a very nice software from 10 years or more than 10 years ago called Visual SFM, from a PhD student in Washington University. And this Visual SFM was a very inspiring tool, and many of people like I did follow and try to use this Visual SFM many years ago. Right now, OpenDroneMap uses an open source implementation called OpenSFM. So if you are interested, you can go and see more about this OpenSFM project, which is just the implementation of the OpenSFM. But also, this OpenSFM is also available as a Docker image, and I do a lot of exercise with the OpenSFM. For example, when I use cameras on the car and try to reconstruct things and so on, I use just OpenSFM and do the estimation of the position of the things using OpenSFM. So first step, structure for motion, and it's a very complex stuff, but basically I'm being simplicist, but we want to estimate the camera position of each photo taken. So really what we want here is to know exactly where was the camera when the drone took the picture. If you know the exact position of the camera, everything that follows will be easier to do. So the next step, if I know exactly where the pictures were taken, I can use the triangulation to create a highly detailed set of 3D points. So the next point, this technique called Multiview Stereo, and the idea is to create a point cloud. And OpenDroneMap has two implementations, so that's why OpenDroneMap is so good. It has several different components that can be plugged to do the same thing. In this case, can use MVE or Also OpenSFM. OpenSFM also has an option to create dense point clouds. So OpenSFM can also be used in this step for creating the dense point cloud. So after you having the many points, you want to collect neighbor points and to create a mesh of very small triangles and to put a color on these triangles. So if this triangle is in a rooftop, and if the rooftop is orange or red or something, you want to put that color on this small triangle. But you are already familiar with meshing, for example, from our tins in our digital terrain models. This usually is a mesh of smaller triangles. OpenDroneMap also have two different implementations to do this. I was talking about meshing and this step, but I also started about texturing, which is the next step. After you identify the triangles, you want to color the triangles, and after you having these small triangles with colors and so on, you can use a view from the sky to create. Sorry. I'm here for georeferencing. No, before everything else, this kind of algorithms always work in local coordinating systems, and sometimes if they don't work in local coordinated systems, they have to work on projected coordinating systems. It's very difficult to work with the decimal degrees and so on. But usually this works in local coordinates. And in this step, sorry, I was already going further. In this georeferencing step, we are just using the EXIF from the images or the ground control points to make the translation between the local coordinates to the real world coordinates. Sorry, there was a typo here. Then we do some DEM processing. OpenDroneMap will try to create compute a digital surface model. So in the output, we will have both the digital elevation model and the digital surface model. The idea is to try to distinguish what are buildings and take the buildings off and see holes and fill the holes and so on. So this is the DEM processing step. And only afterwards is the orthophoto processing, and the orthophoto will take advantage of this texturing and so on, and will create a GeoTIFF, georeferenced. It will take the whole area and all the tins, but afterwards we will cut the orthophoto. So this is mostly trying to explain this complexity and try to divide this in more logical steps. These logical steps are carried out by different software components, and OpenDroneMap, if you want to work on its development and so on, the difficulty is to work with all this kind of software. So you have to understand well what are the outputs of the previous step and what should be your outputs to the following step. But here we have a brief notion of this. So going back to good. We are able to do this in 8 minutes. That's why I put a very small data set with just 30 images, because it's easy to do in 8 minutes. So all done. So if all done here, you can download the assets. So everything it generates, it is here. So we can download even all assets, for example, and store it in this folder, and then extract the folder and take advantage of these assets in QGIS. That's what I usually do. But since we are focused on OpenDroneMap today, we also have a very nice interface, and that's why WebODM is really cool, because you have immediately a view map. So here in the center, it is our orthophoto. You see the chapel here, the previous one there. And you see my street here, cars, and this is the ortho that we made from these 30 images. You have things like a slider to see how this is going. I think we have Google Maps on the background, but you can come here and change the background. And in this custom, you can write down a tile service, and the OpenStreetMap is already here. So it's much better. Oh, and it's much nicer to see OpenStreetMap data here. So our ortho is on top of OpenStreetMap, and you can see that the streets and everything is geolocated. So besides the orthophoto, you have things like NDVA, vegetation index, immediately here. So as you can see, green areas should be areas with more vegetation, although the cars are here with more green, but you can tweak this plant health index, and you also have a surface model here, so you can see the houses here, the old chapel, the buildings, and and you have several tools here, and you can also switch, and this is really cool. Switch to a 3D view. So if you hit the 3D view, you go to Portrait. So OpenDroneMap is really a very huge stack of open source projects, very nice open source projects, and Portrait is used to visualize the point cloud. So we are looking at the point cloud generated. As you can see, or from this side, you just see it looks like a picture, but these are very small texture triangles that are there. So if we zoom, we start to see the details of the point cloud. And this is what you already have in QGIS. So this navigation, and as you can see, you can do it here in Portrait. Portrait has, if you don't know, Portrait has many nice things. And for example, let me check. I can see the height of a building just by clicking there, and he knows that I'm doing something in the vertical, so I can see the vertical, the height of this roof or the height of this one, and you can see, if you can see my screen, he knows that this is oblique and try to divide the 8 in the X and Y. So you have nice things here, but these things are from the poetry, which is already included here, and you can also show the cameras where the pictures were taken. You can see them, which is a really cool visualization of the first step of the structural information where the pictures were taken. So you have more things here. Let me go on because I really don't know about if I'm going.
Yeah, we have about 8 minutes left, George, before the stream will cut off. So.
No!
Okay.
I talk too much. It's my so I also want to talk about trying to get these point clouds better georeferenced. Regarding the exercises, so the second data set is a larger data set. Here you have a larger data set with that one is this one. Let me check with this one with Nadir. This one is Nadir with 230 pictures. So this one took 8 minutes, for example. So just to have a notion, the first one took 8 minutes, adding 200 pictures. So we went from 30 to 230. It goes from 8 minutes to 2 hours. Okay, so you have this data set. If you want to see if your CPUs are going well and so on, you can do this this second attempt with 230 photos, and you will see that it will take, for example, 2 hours. The third data set has oblique images. So in the third data sets, it will be better to have some facades, and the point clouds will be better. And this one has 178 pictures, and it will take more than an hour to process. So that's why I didn't do this processing in the presentation. I just did the first one. In these 8 minutes, I would like to mention the possibility to use ground control points. So ground control points can be used in OpenDroneMap, and the OpenDroneMap here has an interface, and this interface just serves to create a proper file with a ground control point. But to create a proper ground control point file, you have to provide a source control point file and images. And afterwards, we'll see that using this information, we will click on the images and on the ground control points, and you create a link between the ground control point and the image. It's like the georeference tool that we have in QGIS. In the georeference tool that most of you already use, you are trying to find points in the raster and points in the vector map, for example. Here, you will try to find points on both sides, on the image and the ground control points. And just to go, I lost my time to go through this, but for example, to create ground control point markers, I use here they are. I went to the kitchen and stole some cutter boards, and with cutter boards it's quite easy. For example, these cutter boards are plastic, are waterproof, water resistance. It can be clean and so on. And you can put these markers on the ground. Also, it's really good to have tiles. Those not tiles that we use on maps, but the former tiles used in the construction without gloss. So matte tiles with 4 tiles of 2 colors. You can put them on the ground and are super visible. So going a little faster, how we can use precise GPS devices. Our GPS on the drone or GPS on the Androids are not professional grade. The precision is not so good. They only use one frequency. I have a link here for a Spanish producer called Ardu Simple, which are trying to use things like Arduino and chips from U-Blocks to create very nice. So the kit, you end up with something as simple as this: the one nice helicoidal antenna and GPS, U-Blocks GPS here, and you connect it to your mobile phone. You put your mobile phone here, and from your mobile phone you can power the GPS. And this is what you need to go to the ground and survey the ground control points. For the software, I use these software maps. It's made by I don't know if it's a male or female, but someone very friendly from Nepal, able to answer emails and so on. But this nice software is able to connect to an external, and I don't know if this is Tim.
Yes, if we get cut off, just we can run a few minutes over. I'll just reconnect, but we're still good for now. I'll tell you. You'll hear a message saying if the stream cuts off.
Okay, so I'll try to be really fast. So you can check my setup, this kind of device, this kind of software. But the idea is to go grab those points. In this case, we have a Geo Package with the points, and you have to create initial comma-separated value file that you have to call it .txt, not comma-separated value, and then you are able to start this processing in OpenDroneMap. So the idea, the ground control point must be something with a ground control point structure, and then upload the images. But if you have time, the structure itself is something like this.
Okay, let me just check that they can see. I think we're good to go, Jorge.
Okay.
Thanks.
So I was discussing the ground control points and how you can use ground control points here. But basically the workflow is to, before fly, use ground control markers. You can use any kind of ground control markers, but my humble suggestion is to use tiles, matte tiles of 2 different colors, and put 4 tiles in each place, and then use some GPS to survey the points. If you want to do it properly, you have to take some time and stay there for a couple of minutes. With this Ardu Simple that I mentioned in the documentation, and connecting to the national N-trip service, which provide the N-trip service, I can get 1 centimeter precision, which is really, really good. But sorry, 10 centimeter precision, 10 centimeter precision, which is good. So with these ground control points, you make sure that you can have a better georeference data. For example, when surveying these ground control points and then compare to Google Images or Bing Images, you always get bigger errors. So it's not difficult to have 1 meter error, usually below that, but 70, 60 centimeters error are common in Google Maps and Bing Maps. So georeferencing using those sources will not have a very good model. So you have to create this kind of file. Usually I create this on QGIS. So I grab the ground control points as a Geo Package. I put in QGIS. In QGIS, I usually convert them to ODM coordinates. So it's too much things to talk about. OpenDroneMap will not handle the decimal degrees coordinates, and the first step is you will do is try to find the ODM coordinates of the place. So you'll try to see in which ODM zone, and it's north or south, you are, and use that coordinate system. So I do the same in QGIS. I know where I am, but you also have, I've provided a link in the presentation. If you don't know exactly where you are, you can see for your position. There's something, a web service that you can have the zone where you are. And I use this in the ground control point file. So my ground control point file starts saying that I'm in zone 29. Yeah, in fact, in the ground control point, you can use both two different syntaxes. Yeah, I have, that's in the code documentation, but the easiest way, and internally, you will use the proj string. So in QGIS, you can go to and grab the proj strings from the coordinate system. And the input for the ground control point is something like this. The coordinate reference system, the coordinates of the ground control points. So this is the coordinates in ODM of the ground control points and the elevation. And afterwards you put two more columns with zeros. These columns will be replaced with coordinates of the images and the name for the ground control points. And for these projects, for example, I use 5 ground control points. And these 5 ground control points can be uploaded here using the WebODM interface. So just to show you how this works, I come here, I load this exactly the same file. When I do load, as you can see, it gives some feedback about 5 ground control points, and the ground control points are here and shown on the map. Second step, choose images. I'm not sure. I can select all images. And how it goes, it's as simple as it is reading the images. It can display a small preview of the images. Yeah, it's slow, but it's already showing. Yeah, but for example, this is my daughter's school. I know exactly, and I have places on the ground that I know exactly the coordinates. For example, this is not the usual. Yeah, it's the usual way. You know where the ground control points are. In this case, I know that the ground control point is exactly here. So I put a ground control point here, and I say this is the ground control point, and I have a match. So the image turns green and I have a match. And that's the cycle of doing the ground control points. What is important that each point of this on the ground are covered by several pictures. So to have a proper triangulation, you have to tag at least 3 images for the same ground control point. But regarding ground control points, you should put them in a way that they are not in the same line. It's the usual stuff as georeferencing images. You should put the ground control points like this, and afterwards, for example, for this one, I already selected the image, but I should see other images. Yeah, sometimes you have something annoying, so it's good to see these presentations, because if sometimes it creates automatically a point here. So if you try to connect this point, let me just do some zoom. With this one, you are not able to match the point. So if sometimes it creates a point here, so delete it, create a new one, and afterwards you can connect it to the ground control point and you have a red dot. So you have to do this for all these points. In this case, I have five ground control points. At least you have to do it 3 times. So at least 15 images must be used to have at least 3 images for each ground control points. And at the end, you do an export file. Oh, and it's good. It is doing the same mathematics and is complaining about, and it says also pointed to the documentation. But right now, my ground control points is only have 2 entries. But even though I can save it, and usually we save these ground control points. And I would use, in this case, in this school mission, and in the same folder where the image are, I would save this with the extension TXT, ground control points, and it will be used in the next processing. So, not to take much longer, I think it's time to questions, to ask things, and it's your turn to experiment and do your things and see the problems you have processing images, but at least to know how this works, I think the presentation is done. Of course.
George.
Just 1 second. Of course, before everything else, in these assets, when you download the assets, the point cloud is there. So you have the point cloud as zipped here if you don't ask for the non-compressed one. So you can download the point cloud here or download all assets and open the point cloud on QGIS if you already update QGIS to the current master, and you'll be able to take advantage of that.
Thank you very much, George. It's a fantastic walkthrough, and I learned a lot myself. I've been also playing with these tools, but there's always something new you can learn.
No, it was a mess. Sorry.
No, it's wonderful, and I think the resource you've shared on your GitLab is going to be very, very useful. It's such a nice summary of the workflow. I think we can update the YouTube video description. We can put the link into that in case anybody missed it. I think we won't have time for questions now, but maybe we can suggest to people to join the Telegram group. If you're not already joined, you can find the link for the Telegram group on the Hackfest wiki page. And then maybe they can come along there and ask you their questions. I see people are putting nice pictures of their drone mapping work and so on there as well. So it's a good place to come and engage with George. And there's a bunch of other people that also know OpenDroneMap in that group. So it's a great place to come and hang out and share your questions and so on. Okay, thank you very much.
I think it's Pedro. Pedro Benanzi, yes.
Yeah, okay. Okay, George, I think we stop there. Thank you for watching, everybody. We'll be online again in about 15 minutes with the QGIS AMA, which you can talk to George, and maybe you can ask him some drone questions then as well.
I'll try to lunch in between.
Yeah, me too. Okay.
Thank you so much, Tim, and thank you for setting this up.
Yeah, bye.
Bye.